turn on. All right, so we're going to be factoring, and so the first thing we're going to look at is what's called the factor theorem. If you remember with the factor theorem, it says that if something is a factor, that means then graphically it crosses the x-axis at that value, okay, at the 0. Remember, we've talked about that when we were talking about dividing, about using the 0 to factor or to divide and like that for synthetic division. That's because the reason we talked about the 0 is because if it crosses the x-axis at that point, we call it a 0. And we get that from the factors. So when you guys were doing these warm-ups, or doing these problems yesterday, how many of you were actually finding the zeros here instead of just factoring? A couple people did, right? That when you factored, that this one has zeros at 6 and 1, right? Okay, the opposites. This one has a 0 at 0 and a 0 at -4. But if we look at this one here, okay, because it has a coefficient of x, right, then you actually have to solve this equation to find the 0. Okay? So we would add 1 and divide by 2. So the actual 0 here is 1/2, but here it's just 2. Okay? So the factor theorem says that if we have a factor, then when we look at, so if I have the factor x minus a, when I put a in for x, I should get 0. Okay? That's basically what the factor theorem says. So if if you look at the graph of it then, if it equals 0, then it's going to cross the x-axis at that point. All right, so we'll do number 3 instead of doing one of these. Oops. So what we want to do is we want to know oh, come on. We want to find out if 2x minus 4 is a factor. That means that wherever this equals 0, when I put it in here for x, does it equal 0 or not? If it equals 0, then it's a factor. Because that means that if I put that number in for x, the result I get is my value for y. And so if y is 0, that means it's on the x-axis, and it would be a 0 of the graph. So we're going to use synthetic substitution to determine whether it is or not. So first of all, I need to find the 0. Well, if it's not just x minus 2 or x plus 2 or x plus 4, then I actually have to solve this equation to figure out what the 0 is. Now, when we were talking about long division and synthetic division, we said that, well, I can't do, if I have 2x minus 4, I can't do synthetic division with that. But that's when we're dividing, not when we're trying to find the 0. Okay, so there's a whole different situation there. Okay, if I was asking you to divide this by 2x minus 4, you'd have to use long division. But I can use synthetic division or synthetic substitution to determine whether it's a 0 or not. So if I solve this, we add 4, divide by 2, get x equals 2. So 2 is the number we're going to use because that's what causes this to be equal to 0, and see if I get 0 when I do synthetic substitution. So we'll put the 2 in, and 2, -4, 0 because there's no x cubed, 2, -2, -4. So we're doing just like our synthetic division, synthetic substitution. And what we're concerned about when we're all done is what is this number here? Okay. If that number is a 0, in other words, if I have a remainder of 0, then it's a factor. If I don't, then it's not a factor. So we bring down the 2. 2 times 2 is 4, so that's 0. And one person made this mistake from grading the quizzes yesterday. 2 times 0 is 0 when somebody put 2 once, and that messed you up. Add them together, get 0. 2 times 0 is 0. 2. 2 times 2 is positive 4. Negative 2 plus 4 is 2. 2 times 2 is positive 4, so this equals 0. So then 2x minus 4 is a factor because the remainder is 0. So we do synthetic substitution, or basically you're doing synthetic division, so you're using the zeros. So in this example here, okay, I would use negative 2 there because I want to use the 0 just like synthetic division. And if I get a remainder of 0, then it's a factor. If you don't get a remainder of 0, then it's not, because it means that it doesn't cross the x-axis at that point. It goes somewhere else. Okay? All right. So factoring by grouping then. So I'm going to go ahead and I'm going to do this example here, and then I'll do number 6 you asked for, right? Okay. When we want you to factor by grouping, that means that we're going to take the first 2 terms together and the last 2 terms. And we're going to factor the greatest common factor from each of those pairs. Now, you can only do this when there's 4 terms. And it doesn't matter what the degree is of the terms. You can only do it when there's 4 terms. But you put the first 2 together and the last 2 together, and you factor out the greatest common factor. So what do these 2 have in common? X squared. So I take x squared out, and I have x minus 1. Okay. What do these 2 have in common? Okay, they both have a 25, right? Now, there's one little note here. Okay, a little side note. If the third term is negative, then we're going to factor the negative. Okay? So if the third term is ever negative, you've got to factor out that negative. So when I say that these 2 have 25 in common, but since the third term here is negative, I'm going to take out a negative 25. So negative 25 divided by x divided by negative 25 gives me an x. Positive 25 divided by negative 25 is negative 1. So when we factor by grouping, what we're hoping for is just what we got here, that I have 2 things that are the same again. And so this is the way you can think of it. I'm going to factor the greatest common factor again, because both of these have the common factor of x minus 1. I have x squared times this, negative 25 times that. So it's common factor. So if I factor out x minus 1 now, what do I have left? I have x squared here, and I have negative 25 there. And this is the reason why I had you do all that factoring too, a little bit of practice of it, and including the difference of 2 squares, because when we're factoring by grouping, there's going to be a lot of times you're going to have the difference of 2 squares. And so this is x minus 1 times x plus 5 times x minus 5. And that would be our answer. could I factor this if this was a plus sign between them? All right. Now, here's the answer to that question. All right. Take out your calculator. Okay. If you haven't got one, and you may borrow one, or you haven't brought me a sheet yet, you can borrow one from the back, but I want you to see this, or you can just watch me do it if you want. So, but take out your calculator. Wow, is she nice? Okay, now I want you to graph x squared minus 25. So go to your y equals, put in x squared minus 25, and hit zoom 6 so you can see it graphically. Okay, now that crosses the x-axis at 5 and negative 5, right? Okay, so that tells me that I can factor it right there. Okay, if it has zeros, crosses the x-axis, I can factor it. Now graph with a plus sign there. So it's y equals x squared plus 25. Graph that. Okay, and you should probably have the same thing on your screen that I have. Did you grab yours? Turn the plot off. Okay, now, here's the thing, okay? If you understand what happens, if I have x squared minus 25, what does that minus 25 do to x squared? Okay, it makes the y-intercept go down, right, to negative 25. So the graph of y equals x squared minus 25 looks like this, right? It's the graph of x squared shifted down 25. Okay? So what would be the x squared plus 25? Where would that one be at? Not to the right. It goes up 25. Okay? So the graph of that one, if I change my window, so I'm going to go up to 50. Okay? I can see it. But it doesn't cross the x-axis. Since it doesn't cross the x-axis, you cannot factor it. Okay? So I can factor the difference of two squares. I cannot factor the sum of two squares. So if this would have said x squared plus 25, then that step right there would have been my answer. I couldn't have gone any farther. Okay? Just wanted to remind you of that. All right, number 6. Number 6. Okay, so so I'm going to group them together. Okay, what do the first two have in common? Okay, 8 and 4 both will have a 4. X cubed and x squared, they both have. Okay, so we got 4x squared. So then we have 2x plus 1. Now, our third term is negative. Okay, so we've got to factor out a negative. Well, what do negative 2x and negative 1 have in common? Okay, just a negative 1. So we have negative 1 times 2x plus 1. So they both have the common factor of 2x plus 1. So I'm going to factor out that common factor. We have 2x plus 1 times 4x squared minus 1. Okay. Now, how many of you got that far, but didn't go any farther than that? Okay. Now, this is the difference of two squares. All right. A squared minus b squared equals a plus b times a minus b. What is squared here? What's squared to make 4? What's squared to make x squared? What's squared to make 1? 1. Okay. So this is 2x plus 1, 2x plus 1, 2x minus 1. Okay. And that would be the answer. Or if you wanted to, you could write it as 2x plus 1 squared times 2x minus 1. Okay. That would be up to you. All right, we have something called, we've done the difference of two squares. We just talked about that. We said you can't factor the difference of two cubes, but you can, or the sum of two squares. So we're going to look at, what if we have cubes, though? And if you have cubes, you can actually factor them. So here we have the sum and difference of two cubes, and you're going to want to write these down on your note card. Or write them on your paper and then put them on your note card later. Okay. And then we're going to actually make a little table before we go any farther. So, okay, so we have the sum and difference of two cubes. And basically all it is establishing what's the value of A, what's the value of B, plugging them in. Okay? Just like what we were doing with the Pascal's triangle, using that for multiplying out stuff. Okay, when we have expansions. So first thing, always remember that when I'm factoring, we're always looking to do what first? If you're asked to factor something, what do you always look for first? Okay, something to have the same. So the greatest common factor. So the first thing we're always going to look for, is there GCF, the greatest common factor. That's the first thing always. You don't want to start factoring anything until you've looked, okay, do they have something in common? Because if they do, you need to get rid of that first to simplify matters. Okay. So, do these two things have something in common? Okay. 4 and an x. Okay. So first thing we're going to do is take out the 4x. So 4x to the fourth divided by 4x is x cubed plus. What's 108 divided by 4? 27. Okay? So plus 27. All right. So is this a cube? That's raised to the third power, right? Okay. Here's the thing. Okay. Anything raised to a multiple of 3, 3, 6, 9, 12, 15, 18, those are all cubes. Okay? Anything raised to the power of 3 is a cube. Right? Is this a cube? Let me look over here at my chart. Oh, hey, there it is right there, 27. It's 3 cubed. So in this case, then, a is going to be x, right? That's the first thing that's cubed. And b is going to be 3, the second thing that's cubed. And from there, I go to the sum of two cubes. And then I'm just going to plug in so I'll come down here. And where I have an a, I'm going to put x. Where I have a b, I'm going to put 3. So I still have the 4x out front. And then we have a plus b, so x plus 3. Okay. X is cubed plus 3 is cubed. Then we have a squared, so x squared minus, it says a times b, so we're going to multiply them together. Well, what's x times 3? 3x. And then plus b squared, so 3 squared is 9. And that is the answer. Okay? You cannot, okay, whenever you have the sum or difference of two cubes, you cannot factor this any further. Okay? If you did, it wouldn't be the sum of difference of two cubes then. Okay? So you don't have to worry about trying to factor that also, because it can't be done. Okay? All right, so let's look at letter B. Do they have anything in common? Is there a number that goes into 125 and 8? I don't think so. But if I look over there on my list of cubes, is 125 on there? Is 8 on there? Okay. So in this case, A is equal to what? 5D, right? 5D. Okay? Because we have 5 is cubed here, so this is 5D is what is cubed here. And 2 is cubed there. So A is 5D, and B is 2. And it's not negative 2, it's just the number 2. So then now I'm going to use the difference of two cubes. So wherever there's an A, I'll put 5D. Wherever there's a B, I'll put 2. So 5D minus 2. If I square 5D, what do I get? 25D squared. Now it says plus. What do you get when you multiply A and B together? What's 5 times 2? 10. So we have 10D. And 2 squared is 4. And there's our answer. So we look for greatest common factor. Take that out if there is one. Then look, see what I got left. Does it have a cube in it? Okay. If it does, then we're going to factor using either sum if it's a plus or difference if it's a minus, 2 cubes. You can actually use your calculator to graph a polynomial and use that graph to factor. All you need to know are the zeros. So let's look at this polynomial. X cubed plus 6x squared plus 3x minus 10. Okay, it's got 4 terms. So if it's got 4 terms, I'm hoping I can factor that. Okay, factor by grouping. Let's see. What do these two have in common? X squared. Okay, so we have x squared times x plus 6. What do these two have in common? Okay, just a 1, right? So I have 1 times 3x minus 10. Are these two things the same? No, if they're not, then I can't factor it by grouping. Okay, it can't be factored that way. So then I'm going to take my calculator and I'm going to graph it. Okay, so put this in your y equals. And tell me where it equals 0. In other words, find where it hits the x-axis. It probably will be 3 times because it's a cubic. So it should happen, it could possibly happen 3 times. It's going to happen at least once. Okay?
1, -2.
I said it first.
Okay? Becca says 1, -2, -5. How many people can see that on your calculator? Okay? If you can't see it on the graph, you can go check the table. Here's the other thing that I'll do. All right? I love the trace feature of my calculator for this reason. That x cubed plus 6x squared plus 3x minus 10. Okay? Now, I like the trace feature of my calculator because it looks to me like they're specifically at spots, but if I hit trace right now, okay, it looks like there's a 0 at 1. So if I hit trace and then put 1 and enter, okay, it shows me, okay, I'm correct, there is 1 at 0. Okay? I can type in -2. All right, I have a 0 at -2. -5. Okay, I have a 0 at -5. Okay? You can do it that way, or you could just go to the table to check and see. Okay? So we have zeros at 1, -2, -5. Okay? Now, if we go back here, okay, number 5, where is that equal to 0 at? 6 and 1, right? Okay? So if I have a factor of x minus 6 and a factor of x minus 1, then I have zeros at 6 and 1, right? Okay? So if I have zeros at 6 and 1, I could write that as x minus 6 and x minus 1, right? Okay? Here I have zeros on number 10. I have a 0 at, well, let's use number 9. At number 9, I have a 0 at 8 and a 0 at -2. Okay? So x plus 2 would be the factor that gives me a 0 of -2, and x minus 8 gives me a factor, or 8 would give me a factor of x minus 8. So this means then I can write this in factored form, and this one's going to give me a factor of, it's always the opposite,
-1.
x minus 1. So this one would be
X plus 2. X plus 5.
an x plus 5.
That's it.
And I just factored it. That's it.
That's not.
Says use a graph to factor. And so Here's another thing then. You can actually use your graph to do factoring. Okay? The only times it becomes a little trickier, and for those of you who learned how to do slide and divide with factoring, okay, that actually helps you too. But the only place it becomes trickier is if you have fractions. And we'll talk about that later on too. But if you can find the zeros, you can factor it.